Hello everybody, welcome back. So today we will be learning about kinematics of linear motion, which is on chapter 2. So in this chapter there are three subtopics, and the first one is on linear motion. Okay, so for this subtopic you should be able to define what is instantaneous, average and uniform velocity, instantaneous, average and uniform acceleration. Secondly, you have to be able to interpret the physical meaning of displacement against time, velocity against time, and acceleration against time graphs. So these three, they are interconnected lah. The graphs, this graph is telling us about this, and this graph is telling us about this. Begitulah. Okay. And lastly, you should be able to determine the distance traveled, displacement, velocity, and acceleration from graphs. Okay. So firstly, what is kinematics? So kinematics is defined as the description of motion of objects without consideration of what causes the motion. Okay, so that is kinematics. Now the terminologies that you need to know in this subtopic ataupun in this chapter is we have distance, which is small letter d, displacement s, speed v, and velocity v as well. Okay, so please make sure you know what are the definition for each of this lah. Okay, so firstly, distance is defined as the total path length traveled in moving from one location to another. So this is a scalar quantity, so it is always positive. And then the second one, displacement, is the shortest distance between initial and final point. So this one, it is a vector quantity, and it can either be positive, negative ataupun zero. Right? And then we have speed. So speed is a scalar quantity, and it is defined as the distance traveled per unit time interval. So it will have the same SI unit with velocity, but the only difference is this one needs direction. Okay? Astaga, basar pula. This needs direction. Okay? And then for velocity, salah pula. Sorry everybody. The one that needs direction is velocity. Okay, so speed does not have any direction. Okay, and then so velocity is defined as the rate of change of displacement lah. Alright, now let's look at velocity. So we have instantaneous, average and uniform velocity, right? So instantaneous velocity is defined as the velocity at the specified position ataupun instant of time. So the equation is the same as the average velocity as well lah. Okay, and then average velocity is the rate of change of displacement. Uniform velocity is the constant velocity. Please note that for any object moving with uniform velocity, the instantaneous velocity will be equal to the average velocity at any time. Only valid for constant velocity lah. Alright, so now let's look at acceleration. So acceleration is defined as the rate of change of velocity, and it has the SI unit of meter per second square, and it is a vector quantity. So it has direction. Please note that a change in velocity can involve either the change of magnitude ataupun direction ataupun both. Okay, so if the statement is telling us there's a change in velocity, it can either be the magnitude ataupun the direction atau both lah. And then acceleration may occur due to the change in speed or direction ataupun both. Okay, alright, now instantaneous acceleration, average acceleration and uniform acceleration. So similar to instantaneous velocity, for acceleration it is also the acceleration at a particular instant of time ataupun position. So this is the equation, and average acceleration is the rate of change of velocity. Again, this is the equation. So now uniform acceleration pula, it is the magnitude of velocity changes at a constant rate along a fixed direction. Okay, so the direction is fixed and the rate of change of velocity is constant. That is when the acceleration is uniform. Okay, we also have deceleration, where the object is slowing down. So it means that the speed is decreasing with time. So this one, the acceleration will be negative. Okay, jangan kamu tulis D ya untuk kasih tahu deceleration. No, that is wrong. that is also A, cuma dia negative saja. Okay, that is deceleration. Okay, now let's look at this graph here. So this graph here is not realize. There's a relationship between each of this graph. Okay, so if we look at this slope at this displacement against time graph, we can see that this slope here is increasing constantly lah. Okay, so when this increasing slope here indicates there is an increase in velocity. We can see that here. Okay, and this positive slope means that the acceleration is positive. So how do we calculate acceleration? It is dv over dt lah. Okay, so we calculated 10 minus 0 divide by 5 minus 0. Macam tu lah. Is it 10? Oh, sorry, it's not 10. Somewhere here lah. Okay. Alright, next we have a decrease in this slope here. Oh, sorry, we need to do this first. Kejap, let me just check where we have discussed. Okay, now we can look at this part here where the slope is constant. Okay, when the slope is constant, it is telling us that the velocity is constant. Okay, and this horizontal line here means there is zero slope, m equal to 0, gradient is equal to 0, telling us that the acceleration is 0 because the velocity is constant ataupun uniform. Okay, so that's why you see the acceleration at this part is equal to 0. Right, so we've discussed this sudah. And then let's look at this point here. So this horizontal point here implies that there is a 0 velocity. Okay, so at this point up till this point, the velocity is equal to 0. Okay, if you look at this point, the velocity is equal to 0, and this slope here indicates that there is a decrease in velocity. Okay, this part here. Okay, so that decrease in velocity is telling us that there is a deceleration. Okay, so that's why it is negative at this part here lah. Okay, and then if you look at this point lagi, negative slope indicates there's a negative velocity lah. Okay, so this negative slope here implies that there is a negative acceleration. That's why sekarang pun masih lagi negative. Okay, next is apa? Okay, so at this point pula, we can see that this curve is flattening, which is telling us that the velocity is becoming less negative. Okay, so it is going to 0, like it's gonna slow down and then it's gonna go to a stop. Okay, so the acceleration here is positive sebab the final is greater than this negative value here. Okay, that's why the acceleration is positive sebab dia sedang accelerate and then there goes to a stop. Alright, okay, so I hope you are able to understand what I'm trying to do here. Basically, we need to be able to describe what is happening in the graph. Okay, I'll add another piece of note after this here, which is much more detailed in explaining what's happening in these graphs. Okay, all right. Okay, let's look at example number 1. So a car travels in a straight line along a road. Its distance s is given as a function of time by this equation here. So we have to calculate the average velocity. So the average velocity of the car at the time interval of 0 seconds and 10 seconds. And then calculate the instantaneous velocity of the car at 5 seconds, instantaneous acceleration at 5 seconds as well. Okay, so now we know that the average velocity, so we know that the average velocity is equal to delta S over delta T. Okay, so we know that T final is equal to 10 and the initial time is equal to 0 second. And then we know that the initial distance is also equal to 0, and we need to find the final distance. So how do we do that is we substitute t, this is equation 1 lah. Let me just label that. Substitute t equal to 10 second into equation 1. So from here we can get the distance at t equal to 10 seconds lah. Okay, 0.2 10 cubic, so this one we will get 120 meter. Okay, so from here we can then calculate the average velocity, which is equal to 120 minus 10 divided by 10 minus 0. Sorry, 120 minus 0 divided by 10 minus 0. So we will get 12 meter per second. So that is the average velocity of the car lah. Okay, and then the instantaneous velocity at t equal to 5 seconds. So we need to substitute t equal to 5 seconds. But now this is asking about velocity. So this equation is not for velocity. This is for distance. So how do we do that is we need to derive the, no, sorry, not derive. We need to differentiate this equation in terms of t. Okay? With respect to time. Okay, so that is differentiation. I hope you are still able to differentiate. Kalau tidak, you will have a problem lah. Okay, so for differentiation, the power here will be minus 1 because this number, this power, you will be bringing it to the front here, multiply it with this and this. So you will get 4.8t minus 3 times 0.12, you will get 0.36. The power of 3 will be reduced by 1, so you will get 2 here. Okay, and now we have the velocity punya equation. So after this, we can then substitute 5 into t lah. Macam ni, 36. So this is 5. You will then get 15 meter per second as the answer for the instantaneous velocity. Okay, next, the instantaneous acceleration again. Now acceleration is the rate of change of velocity. So again, we need to differentiate this equation in terms of t. So v is 4.8 t minus 0.36 t square. Okay, so differentiate this, you will get 4.8 minus 2 times 0.36, you will get 0.72 t equal to 4.8. Substitute the value of 5, substitute 5 into t, you will then get, let me just write it down, you will then get the acceleration, the instantaneous acceleration, to be equal to 1.2 meter per second square. Example 2. So based on the graph below, we have to describe the motion of the particle. So firstly, what you need to know is anything going away from 0, anything that is moving away from this 0 is gonna be increasing. Okay, so it is increasing. This negative and positive, wait, I need to put one more. So going closer to 0 means it is decreasing in value. Okay, and then for the positive and negative, kan di atas ni positive, di sini ni negative. So this positive and negative is just telling us the direction. Okay, so kalau dia sudah pergi negative tu, maksudnya dia sudah change direction lah. Okay, so ini, let me just write, it is about direction. Okay, apa lagi? What should I let you know? Tidak sudah, itu sajalah. Okay, so let us solve this. So from point A to point B, you can see that this is a constant, apa tu namanya, increasing constantly. So increasing at a constant rate. So this is gonna be apa tu, velocity increase. Velocity increases. Velocity increase and the acceleration is positive at a constant uniform acceleration. Macam mana mau tulis? Acceleration is positive. No, let me just write uniform acceleration is constant rate of acceleration. Gitu je lah. Constant rate of acceleration. Constant rate of positive acceleration. Gitu je lah. Positive lah kita taruh sini. Okay, and then point BC pula. You can see that it is moving closer to 0, meaning that the velocity is decreasing. And then the acceleration is negative. Okay, but this is again constant lah. Sebab this here is also constant. Okay, and then point CD pula. As you can see, it is moving away from 0, so the velocity is increasing. But the acceleration is negative. Okay, so acceleration is negative. Acceleration is constant also, huh? Constant. And then point DE, it is moving closer to 0. So the velocity decreases at it as it is reaching, I think it is going to a stop. So velocity is decreasing lah, okay? So velocity is decreasing, it is accelerating at a constant rate lah. Acceleration is positive. Constant also. Okay? Alright, so that is how you describe the motion of the particle lah. Okay? So the usual misconception is people use deceleration to describe acceleration lah. Tapi kamu jangan use deceleration. You just use acceleration negative atau positive. So that is the end of our first subtopic.